So there's basically.
You move the mouse. You can move it off the screen.
Well, then you won't be able to control the
Oh.
It's big enough.
I think I can move it there. So anyway, yes, so some changes to or enhancements that have been worked on to the audit interface. Just real quickly, basically, there's some multiple interfaces, and it can basically have more than one. Multiple instances of an interface, and then we introduced a new interface as well, and finally just some examples of how to pull some data out of the audit system. So for multiple interfaces, what's new is that basically they'll be able to have multiple audit logs. There's a new format on the audit log. You can basically specify optionally an interface name, colon, the file spec, or whatever was the traditional parameter of the audit log, and then finally colon and some additional fields that can be passed to an interface if it needs it. If you don't, you can basically just leave it alone and just use the regular, the original format, and it'll still continue to work. So operationally, the audit log parameter stays the same. You don't have to change scripts for things to continue to work the same way. So, and just some examples of how you would do it. So here's a file pointing to a file path. You got the system 5 MQ pointing to a token, and there you can see you can specify more than one on the list. What's changed? So that was what's new. So what's also changed is that the meaning of audit interface has changed, but it doesn't really change operationally. Because now we can have multiple audit logs, the audit interface parameter now sets the default interface that will be used. And the default interface is the file interface, which makes it behave exactly like it was before. And internally, there were some changes to the audit code that basically has a list of the active interfaces, and it just runs through the list. In other words, when it needs to send a buffer, it basically says, okay, I'm going to start the first one, send it, and I'll just keep on calling the different audit ops functions for each element of that list. So the next thing that was kind of added into this was multiple instances of an interface. So you not only can have something going to the file in system 5MQ, you can also have multiple audit logs in file audit logs. So you can basically see audit log, I want this one to go into audit log 1, I want this one to go to audit log 2. Here's an example of using the interface parameter to change the default, and you can kind of see some other examples there. Internally, in order to support the multiple interfaces, the interfaces basically now will have a context that they establish, and then we also relocated the append message function from the individual audit interfaces into the audits. It's only done once instead of each interface invoking it. And there was also a reduction of the scope that the audit log was held. Prior, it was basically done at the very beginning when the message was being composed. It was acquired and then released after everything was done. Now it's the process of composing the message is done with the buffer, and there's no need to have it locked. And the lock is only maintained while we're running the interfaces itself. So this was actually, a lot of the work was done in order to support this facility right here, which is a new interface pipe, which is a named pipe or a FIFO pipe. And so it creates a new named pipe or uses an existing pipe if it's available. It creates a separate thread and a buffer to avoid blocking the main callers of the audit facility. So the problem, kind of looking at it, was that main pipes would block when when a reader isn't connected or the read process doesn't consume the data out of the pipe fast enough. And so the solution is that we set up a separate thread that will handle all the operations that are tied in with the pipe. So, the process of opening the pipe and writing to it are all done in a separate thread. And that basically eliminated the problems of blocking. Buffers are used to pass data from the main audit code into the pipe interface thread. You don't get anything for free, and the cost of this is that there's a possibility that you may still drop some audit records in this process if the buffers fill up. So if there's nothing connected to the pipe, or if the process isn't consuming it fast enough, we won't block, but we will drop some records with it. So the size of the buffer is configurable, and this is where we're actually using that third parameter. So we can say up equals 16 meg. The default is 4 meg, and it can go from I think go from one. I think it's like 1 meg up to 1 gig of space. And so because event records can be dropped, there was two things that we kind of did, and one of them was that we prepend, and this is just for the pipe interface, we prepend the messages with a sequence number. And the sequence number will roll over if it reaches the max value or max event. And if we detect that we are dropping records, we will insert into the stream once we have room to hold the records. We will insert a new audit event record that basically lists, by the way, we've dropped a number of records. Here's the first sequence number that we dropped. Here's the last sequence number that we dropped, and some timestamps that are associated with that. So, as Andrew the other day was showing yesterday was showing the performance stuff, that kind of came as we were looking to stress test this, and Andrew kind of used his system that he was using for doing some of the performance measurements. He was able to get roughly 200,000 to 250,000 audit messages per second. Of course, the mileage may vary. This is professional time, we're on a closed course. We were really looking at trying to minimize, how much time was really spent on the main thread or the main processes, and not to impact the main, the caller of the audit facility, and to try to defer as much as we could into the secondary thread with it. And so with that, there's some considerations. One, in terms of what we did, we really didn't change the behavior of the file for the sys5 MQ nodes. We didn't make them threaded or whatever. basically just made enough changes to basically add the context and move some, some of the functions around, but they behave exactly like they did in the past. So any existing code or any existing interfaces that you're using with it should behave exactly like it was in the past. Though there is a caveat, running multiple file or sys5 MQ interfaces may have a negative impact on the overall performance. We're running these things sequentially. So we'll call the one interface, wait till it's done, call the second interface, wait till it's done. It just happens to be that the pipe interface is very efficient. It basically says, here, we're going to put the data into a buffer and we're done. And we also signal the other side that it's available. And so there's really, for the pipe interface, there's not a lot of syscalls that are happening during the processing on the main thread. All the syscalls are really happening over in the secondary thread, the consumer thread of that process. But file and the sys5 MQ, you have all the system calls that are still there. So you're writing buffers, flushing buffers, or what have you. So really to use this, the list of the audit events, as in historical lists, are documented in the admin guide in Appendix D. There's a list of AIX audit events. My understanding is that the audit facility originally had its origins in some of the AIX auditing system, and so a lot of the stuff is there. And then I guess it was repurposed for just generating some just general audit records that are out there. And so this is an example of how to pull data and put it into Kafka. I'm not sure whether folks are aware of what Kafka is, but it's a data collecting system that basically you can send messages into. And so what we have here is we basically set up on the primary say audit log pipe and send it to the Kafka to some sort of named pipe. And then as a secondary process, we basically point to Kafka provides a utility that reads from standard in and just sends it into the Kafka system. And what's that?
The question about whether we use Kafka, that's yes, because we're the ones who asked.
Yes.
Kafka is a message queue.
Yeah. And so there's a bunch of options on that utility that you can buffer things up, compress things, and batch things up. But that's basically roughly the facility for it. And I have this almost replicating the file interface. I say almost because we do change the format of the records. We have that prepended message sequence number, and we also have the dropped records in there. So you theoretically could get a dropped record. The one thing that might help too, particularly if you're starting up a system or starting this up, is to actually have the name type pre-allocated before you start the server. And that way you can connect the consumer process or consumer task to the pipe. And then when the service comes up, it's already there and ready to go, instead of starting it up and then, or starting the AFS service and then connecting the pipe or connecting to the pipe. And I'm going real fast here. So you have so what you can use with this, basically you have the traditional auditing purposes with it. From a security standpoint, you need to know what's going on in the system. you'll have to make the decision whether the dropped records are going to be acceptable in that situation or not. If they're not acceptable, then you're going to have to bite the bullet and use the file interface to collect like a security logs or security audit events, with the knowledge that that just by nature you're going through a lot of system calls with that, and as Andrew demonstrated, that will have some sort of impact to the performance. I don't think we checked to see whether the latest, what we did do a performance test of the latest bit of changes that we made to it, where we reduced the scope of the lock, how much that has an impact with it. So, but the other purpose, and I think this is the purpose that was the use case, was looking for inactive objects. I think the particular case was looking for inactive volumes. So you can basically use this to monitor to see if a volume is in use, and or a file object is in use, and use that as just a way of doing some house cleaning of some stuff. You can also use it for usage patterns. You can maybe use it just to monitor, for example, you could have a situation where you want to test, was this particular file distributed out or something of that nature or used. So you can maybe use the audit interface for something of those natures. And so, currently, the only spot that this has been implemented right at the moment is on the file server command line has been updated to support the multiple interfaces. Due to the nature of how the audit facility works, it kind of shows up for the other ones. You just don't get the ability to be able to specify multiple interfaces for there. So what needs to happen yet is a command line support to the remaining services other than the file server, some more some internal reviews on it, and then finally submitting this up to master. Is kind of plans for this. So that's really that's the enhancements. Really, probably one other thing too. Let me kind of go back. This is just a technical thing. Just an internal thing. I just want to mention is that looking for a common utility, or a common function to do some human number processing was also added into it as well. So just to maybe have that as an available thing that found one function in there that almost did what it was.
It started working with something similar for the auto tuning thing, but I think yours is better.
And so, and then there's also a the flip side. There's also a function added that will take a number and convert it back into a human readable value as well, just for symmetry. So
where did those end up in your computer?
They
end up living?
They ended up they ended up in util. So I think the function names are util get human byte. I think it's 32. I think so.
So it turns out there's an old and under-distributed node that libutil is supposed to be deprecated.
Yes, it's supposed to be deprecated. Ask Ben if it's okay.
I can move it elsewhere if it needs to be. So.
It should be pretty straightforward.
Yeah. Okay.
So, but anyway, I just wanted to kind of just bring that up with it.
Just for anybody who cares, the use case why we asked for this is we currently have something in place using the old interface that
The system by message.
yes, that each day keeps track of was a volume accessed and by whom, but it only tracks the last access to the volume by that user and host IP addresses. And we build reports and our end users look at it and then they go, well, my software says it's using this volume, but I don't know what I'm using it in. There's 5 million files in there. I don't know what's using it. I don't know, why this guy in Tokyo is hitting it or something like that. So what we want to do is actually audit every single file access. And it's going to be about 35 billion records a day. 35 billion records a day across our plant. So we're not sure whether we do one cell instrument at first and then look at the data and see what we get from that. But we're just talking about a lot more data than processing.
Yeah. So I'm kind of getting the impression that like having the neighbor pipe interface sort of makes the audit interface actually usable for that sort of use case. Because the performance is terrible with the
Well, and the system 5 message queue is a little more annoying to access. It's like, it's a weird area of POSIX that most things don't understand. Specifically, apparently, there's no way in Java to do it without J&I.
Right.
And, other stuff. And you have to pull out messages like one by one. And if you want to send them somewhere else, you have to like reconstruct strings. Here, if you copy it to another file, it's just, you just cat it one place to another. So there's no processing.
And it's hard to have multiple listeners. You have to build like daisy chains or something.
And so basically internally, particularly for the pipe interface, we do a lot of buffering. When we basically get there's 2 buffers that are maintained. So whatever you specify on the buff equals double that. So if it's 16 meg, it's actually 32 meg. When the data actually gets handed over to the second thread, it's like, okay, we have all this data, it's all ready to go, and it just simply goes out fairly quickly. So,
And so it sounds like when you do fill the buffer, you just keep what's in the buffer and you start dropping new things.
right, yes.
Drop new
Yes.
stuff. So I kind of wonder if there may be an optional thing to insert a audit event, not just when you are dropping things, but also if the buffer is more than a certain threshold. So then processing that and say,
Yes.
oh, I'm close to filling up, I need to slow down. Or something.
That was something we discussed, but
Yeah.
we didn't want to gold plate this. So
Yeah, so there is a facility within the audit facility, and I didn't mention it here, that you can send a SIGX CPU to the process, and the audit facility will basically invoke if the interface supports it, there's a statistics.
what you're referring to is before you made any
Right.
changes. It's the
Yeah.
original,
Yeah.
the debug dump stuff, right?
Right, yeah. So there was some debug dump stuff. And so in there, we've added for the pipe interface, we basically say, well, this is how full the buffer is. Though if it fills up, it's right now we're not resetting the size, the max size. And I'm thinking,
So like the sys5 message queue, they have some counters and stats in already, but to get that information, you have to send it the signal, which is really painful.
And read from the log.
And then read from this file, and but it's really painful. You wouldn't want to do it like on a real server. Because it holds like global locks and dumps, I forget what it dumps, but it's very painful.
Oh, I love holding global locks and performing Cisco IO.
Yeah,
So much
we dump,
fun.
don't we dump like the callback table or something?
I don't think you dump, it's not an obscene amount of data. It's just stats on a whole bunch of different things.
Yeah.
I don't think you dump it.
So it is a bit painful, but that's already exists, and maybe Marcia's gonna talk about stats tomorrow.
Yeah.
And, that's tomorrow, right? Maybe there's better ways of getting that information out, the counters out.
Yeah, so dumping stats like that to the stream is one way of doing that for, it seems convenient for the audit interface, but something that's really annoying is how we have like statistics that are reported in 10 different ways. So that would be particularly one more way.
So let's go for
Let's
that.
take them all over. The other ones will go away. This time for sure.
Right. We need one more standard.
Well, I mean, it's not like the same stat. I think it's probably true that in a few places they do, but it's not like we have 10 different ways and we have the same stats in all of them.
Right.
It's different stats are in different ones.
Any other questions for Cheyenne? Thank you, Cheyenne.